What's up, my pre-cal students? It's your boy, Mr. Podvin. We're going to go ahead and actually add to our nice restricted inverse function unit circle. So what we're going to do is we're going to take that. We're going to add some things to it. So right now we've got all of our values on the circle, and we know where to look, which quadrant to look at. We've got some domain and range kind of stuff down here at the bottom. We know to avoid the third quadrant. But what I want to do on the back is I actually want to put a really nice brain dump on there. So we're going to flip this over to the back is what we're going to do. So we're going to take this over to the back. We're going to do a nice brain dump, which actually is on my board. I put it up next to the thing, so you actually can see it next to my thing over there. But it's going to have to do with this. We're going to have theta. We're going to have our regular cosine and sine values. Okay, we're going to have our tangent. We're going to have our cotangent. Okay, it's going to be a nice reference for us. And then we're actually going to put secant. So what we're adding, normally I just do these ones. I just do theta, cosine, sine, tangent, and then we kind of just figure out the rest of them from there. What I actually want to do is I actually want to add it in here so that we have all of them. So we're going to have secant and cosecant theta in here too. So we know what all of the possibilities can look like. So we're going to know what these values look like as we're going. So when theta is 0, cosine's 1, sine is 0, tangent 0, cotangent's undefined. And then, let's see, secant would also be 1, and then cosecant would also be undefined. Okay, so that's for a theta of 0. Okay, and then we'll move on to pi over 6. We're going to stick to our principal angles here. So that's going to be root 3 over 2, and then 1/2 for that one. Okay, that brings us to root 3 over 3 for tangent, which then flips to root 3 for cotangent. And then lastly, we've got 2 root 3 over 3 for secant. And then cosecant will just be a straight up 2, okay? So these two are the results of actually flipping these other two. So remember, these are the reciprocals. So if we take cosine and we flip that, when we go ahead and solve a little bit, we did this in the unit a couple times before, we would end up with 2 root 3 over 3 for that one. And then if you flip 2 over 1, you end up, or sorry, 1 over 2, then you end up with 2 over 1, which is just 2. So that's going to be what we would expect for pi over 6. So then we'd have pi over 4. Pi over 4 is root 2 over 2 and root 2 over 2. Okay, and then we have tangent of that is 1, cotangent's also 1, and then we get root 2 for both of these guys. Those are our reciprocals for those ones. So that's our pi over 4. Okay, pi over 3. 2 more to go here. This one's just, everything's flipped from pi over 6, so it's 1/2 root 3 over 2. Okay, and then our tangent changes to root 3, which then flips to root 3 over 3 for cotangent. And then lastly, we'll have 2 for secant, and then 2 root 3 over 3. There we go. Last one, we've got pi over 2. Pi over 2 has a 0 for cosine and a 1 for sine, which means that tangent's undefined. Cotangent is 0, and then we end up with undefined for secant, and then cosecant, we end up with 1, just like that. So here's how this helps us. Okay, this helps us in a couple ways. It helps us as a nice reference. We can look at this as we're going through homeworks. If we need to look through this, we're going through problems, we can look at this. We know what to be looking for particular values as we're going through these problems. And it's just a great reference. And, honestly, I mean, if you can memorize this much, then memorizing it would be great, because this would be a great reference for you as you're going through certain things, although it takes a little bit to write, as you can see. But again, it's really just like having the other side. It's a good reference to just so you can kind of look at it, and as we're going through the motions, we can kind of like see these as we're going through. Okay, so we're going to use this reference as we're going to go through. So now the next thing that you guys are going to need is your Trig Worksheet 1, which should be done by now. Just saying. All right, okay. Then worksheet 2 is what we're going to actually work on today. So we're going to see what those ones look like. A little bit of composition ones. Yesterday in class we actually did 16 and 18. Make sure you can do 17 from down here in the bottom. Okay, you guys are going to be responsible for the evens on here. I'm going to go through and solve all of these odds, and so that you can see how this works. You guys are going to be responsible for evens. This whole worksheet, so worksheet 1, worksheet 2, so front and back, evens, both sides, except for obviously 17. That's our exception because this is going to be one that I left for you guys. That's all due on Friday. Okay, so you got to make sure you have evens this side, except for that random 17. I'm going to grade that one too. Okay, so make sure you guys have those ready to go on Friday. I'll maybe answer a couple of questions on Friday, but that would be it. All right, let's get right to it. So on the inverse trig worksheet 2, we're looking at number 1. I'm going to go ahead and do all the odds. I'm looking for inverse cosecant of -1. So again, I'm looking at where, again, I got this nice reference here. So I'm looking at cosecant. I'm looking at this one. I'm looking for where is that equal to 2. And if I go down my thing, there's my 2 right there. So my principal angle for that one is pi over 6. Okay, cosecant also happens to follow sine in first quadrant and fourth quadrant. So that's a positive 2 there. So that means we're going to be in our first quadrant. So that's going to just be pi over 6. Okay, going down the line here, I got inverse secant of 2 root 3 over 3. So I'm looking for secant. Again, I'm over here on secant. Okay, I'm looking for 2 root 2 over 3. I see that right here on, again, pi over 6. So secant, let's put this guy over. Secant goes in quadrants 1 and 2. Okay, it's between these two. Where it's positive, like this one is in the first quadrant. So what we're going to do is we're going to say, hey, that one also is pi over 6. Huh, weird. Okay. Now, inverse secant of -2. So inverse secant of -2. Now it's negative. So the only place where we find negative secant values is just like cosine. We're going to find those in the second quadrant. So we need to make sure we're looking at our angles over here. But secant of 2, so if we go down the list here, secant of 2 is right here. That's at pi over 3. So we want to find the family of pi over 3s. So over here in the second quadrant, I've got a pi over 6, a pi over 4. There's my pi over 3. So this one's going to be 2 pi over 3. 2 pi over 3. Okay, moving right along here. We get into our composites. Okay, now we've got a sine of 5 pi over 4. So this is like our regular unit circle, and we're getting a value out of it. And then we're going to take the inverse sine of that. Well, okay, let's do it. So sine of 5 pi over 4, that just happens to be in the third quadrant, where it is negative root 2 over 2. So that's really turns into inverse sine of negative root 2 over 2. Okay, once we know that, inverse sine of root 2 over 2, we can go over here. Inverse sine will be right here. Sine of root 2 over 2 is right here. So that's pi over 4. But this is negative, so we got to go in the negatives for sine. Negatives for sine are down here in quadrant 4. We want negative pi over 4, where it's negative root 2 over 2. So we want negative pi over 4 is our answer for number 7. Moving right along, we got number 9. Number 9, we have tangent of 5 pi over 4. So, hey, we're sticking with 5 pi over 4. So, tangent of our pi over 4s. So, here's pi over 4. Our tangent of 5 pi over 4s is 1. Okay, and then 5 pi over 4 is in the third quadrant, where it just so happens to still be positive. So, what happens here is this guy turns out to be just positive 1. So, this turns into inverse sine of 1. Okay, so inverse sine of 1. So let's take a look. Sine is 1 at pi over 2. So there we go. This is pi over 2. Again, we're going frontwards and backwards. We're getting values from angles. We're going to plug those values into those inverses. We're getting angles back. All right, moving right along. Here's number 11. Now we've switched it. Now we're getting the inverse first. So inverse cosine of negative 1/2. So again, we're negative 1/2. But we're going to look at our chart here, look for just a regular 1/2. So regular 1/2 is at pi over 3. So pi over 3. But we need to be negative for that inverse cosine. And remember, that's in the second quadrant. So we want 2 pi over 3 because we're going to be sticking with that pi over 3 family. So this thing is 2 pi over 3. All right. So this is really what we're looking for is this turns into 2 pi over 3. So we have sine of 2 pi over 3. Okay. So sine of 2 pi over 3. So we're talking second quadrant. Okay. We didn't write it on our this one. We didn't put it here, but it just so happens to be positive in the second quadrant, and it just so happens to be root 3 over 2. Okay, because that is root at pi over 3 family, it's root 3 over 2, and it's positive in the second quadrant. So there's our answer for number 11. It's root 3 over 2. Let's see, 2 more. Inverse sine of 1. So inverse sine of 1, that's 1, right? Oh, there it is, pi over 2. So this guy's pi over 2. Interesting. Okay. So then we've got tangent of pi over 2. Uh-oh. What happens when we take the tangent of pi over 2 undefined? So we're off the scale. We actually end up with undefined. Okay, so that one ends up being undefined on that one because the tangent of pi over 2 is an asymptote, so that's undefined. Let's see, last one here. I've got inverse tangent of 2 pi over 3. Sometimes these ones work out to where these things just kind of cancel each other out, but we have to be very careful with those because sometimes we get outside of our domain and range. So I like to just say, you know what, we're going to go ahead and figure it out because let's just figure it out first. So that way we're not messing ourselves up. So let's look for a tangent of 2 pi over 3. Well, tangent, let's see, tangent of my pi over 3 family is root 3. Okay, but 2 pi over 3, that guy's in the second quadrant here. 2 pi over 3. In the second quadrant, tangent's negative. So this is going to be negative root 3. So there's our issue there. That's negative root 3. So that takes us to this. We've got the inverse tangent of negative root 3. We'll see if we get that same 2 pi over 3, if we get something different. Let's take a look. So if I take a look, same thing, right? Tangent of pi over 3, but this time it's negative. Okay, so it's negative. When we're doing the inverse tangent, though, the negatives have come down here. Notice we don't have any tangent values over here in the second quadrant, so we're not going to be pulling from there. We want to pull from right here. See, it's right here at negative pi over 3. So what ends up happening here is our answer is negative pi over 3. So, you know, normally when you take an inverse, take the inverse of an original function, you get the exact same thing back. Sometimes in trig, what happens is you take the inverse of something, you end up with something totally different. And thus is the way it goes. Okay, so we found negative root 3 happened to be at negative pi over 3. That's where our tangent worked. And that's where we good. So now, the rest is for you. You've got the evens, and you guys are due. Those are due tomorrow. Let's see, Friday. And yeah, that's the idea. So we'll see you on Friday, and keep being awesome, you guys.